Hi, and welcome to this part 6 of our V-block series video. Today, what do we have to do? Well, we have three things to do. We're going to be drilling a through hole in each one of the blocks. And they are really just through holes. Now, on some V-block sets, you get the V-block with a very accurate hole through it that you can use to align a couple of blocks over a certain distance with a very accurate pin or bar. But that's not the case here. This is just really a through hole. It's actually a clearance hole for a 3/8 screw. Why? Well, when I designed these blocks years and years ago, I designed them as a school project. And I put that hole in them to make it easier to hold them up onto an angle plate for the final grinding. Now, that is important because in school I want to make sure that things are fixed properly, and that's why I put the hole there. But if you want to make it more accurate so that you can use a bar to line up your V-blocks, well, go ahead and do it. There's no problem there. Now, that is one thing. The next thing we have to do is going to be rough out the V on both blocks. And remember, the blocks aren't quite the same size, so I'm going to have to adjust there for that. And then, well, we have a slot, a clearance slot at the bottom of the V to produce, a 1/8 wide slot that just clears the inside corner so that a square part can sit without touching on its intersection. And that's what we have to do. And all of that starts with a good layout operation. And I'm going to be laying out everything at the same time so that we won't have to come back as the project progresses or as the video progresses to come back to do some layout work. So we're going to put a thin coat of glue on each end of each part. Let's take a look at that. So it's important to remember that we've left material on these parts for finishing. Now on this small block we've left almost nothing. Really just about 5/1000ths of an inch overall, so a couple of thou per side is all we need. And that's why the first line that we're going to lay out for that clearance hole is not at the 0.5 inches that is indicated on the plan, but it's going to be laid out at 502/1000ths of an inch. And that's what I've set my height gauge to. Actually, I've set it to 1 inch 502 thou because remember, this height gauge doesn't go under 1 inch in height. So I set it an inch higher than what I need, and I set my part on a 1, 2, 3 block to raise it by that extra inch. When I come to my second part here, well, I've left a lot more on. Actually, in the height of this larger block here, I've left 28/1000ths of an inch extra. So that means 14 thou per side, and that means that I'll be setting my height gauge here to 1 inch 514 thou. So we're good to go with laying out those first lines. We're going to lay out one line on each end of each block. So let's take a look at that. Now I want to produce the line in the other direction to mark the position of that hole. But where is it? Well, it's 1 inch from the edge. We can see on our print here. And both blocks in this case measure the same width, which is the width of the bar they came from. Remember, I couldn't leave extra material on there because the bar already measured 2 inches and I'm way too cheap to go and buy more material. So that's fine. I'm going to lay out to 1 inch from my edge. Now this height gauge can make it to 1 inch, so I can dispense with my 1, 2, 3 block and seat the part directly on the table. And yes, my height gauge is already set at 1 inch, so let's do that. Now I want to lay out my V. And there's several ways of doing this, but if you want to do it very accurately, you're going to have to do a lot of calculations. Now, the best way for this, since these laid out lines are only going to be used to guide my roughing cut, well, would be to find an intersection on the V. Now, this V intersects itself at the bottom, and that point there would be easy enough to calculate, so I could use that intersection to start. But that would imply laying out a line lengthwise along the center of the V. I don't have to do that really, because I have another intersection where the top of the V intersects the top plane of the part. That's a nice clean intersection that I can use to set my height gauge for laying out the V itself. So that's what I'm going to do. And if I look at the plan here, I can see that that intersection occurs at 400 thousandths of an inch from the outside edge of the part. And since I have no material left on the width of the part, well, I really have to just set up to 400 thou, 1 inch 400 thou, and I'm going to use my 1, 2, 3 block to raise the part. That means, however, that since this block has nothing left on its height, or very little, about 5 thou, the laid out lines I'm going to produce here are going to be very close to the finished surface of the part. But that also means that on this larger block, where I've left 28 thousandths of an inch on, well, that laid out line is going to make my V, my laid out V, quite a bit higher. And that means that I'm going to be leaving material on the V there for finishing. And lo and behold, that is what I need. So that is what we're going to do. Now that I have that intersection, well, I have something to base the start point of my line on. For me, I'm lazy. Well, I'm going to use this nice V-block that I made 40 years ago when I was an apprentice, or maybe a little more than that, to position my part at 45 degrees. And then I'm going to set the height, well, I've already done it, set the height of my height gauge so that it just comes equal to that intersection that I've just created. And that'll be where I want my line. So then I can lay out both of my parts that way. Now, you may not have a V-block in your small home shop, and that may be why you want to make a V-block set. So it's quite understandable. You don't need the V-block. You can get away with a protractor or with a head of a combination set, a square 90-45 head, and you would use that on your surface gauge to position your part up against an angle plate and clamp it down onto it to position it at 45 degrees to do exactly what we're doing here. It just would take a little while longer, and I am lazy, so I'm doing it this way. So I'm set up and good to go, so let's lay out those lines. All I have left to do now is to produce a line indicating the depth of the groove at the bottom of the V. The width I'm not really worried about. I mean, the cutter I'm using is a 1/8 of an inch slitting saw, and it's going to give me my width. I'm going to get to center by numbers, but the depth I'd like to have something to gauge by. And that means that I'm going to scribe a line or lay out a line. And if I look here, the bottom of that groove is 1 inch 50 thou above the bottom of the part. Now on my small block, that means that I'm going to lay it out pretty well at 1 inch 50 thou, actually 1 inch 52. And for this larger block that has 14 thousandths too much on the bottom, or left for finishing, well, I'm going to lay out that line at 1 inch 50 thou plus 14. So 1 inch 64 thou. And I'll lay out the line there. And then my layout will be complete. And there you go, the layout is completed. Well, not really. My official layout is complete, but I have one more line that I want to lay out that really has nothing to do with an operation on this part, as that it doesn't represent an entity or a dimension. And that is, I want to produce a line in the center of the part height-wise. For two reasons. Well, the first is eventually I'm going to want to cut this part into two, and I could refer to that line to help me set up my cut-off bandsaw. That's not the only reason. When we drill a part, and these holes are not accurate, so I'll be drilling through on the drill press. So I'm going to punch, spot, and drill. Now this small block here, I'm going to drill right through. But this larger block could be problematic. Why is that? Drills, well, you know where they enter the part, but you're never sure where they're going to come out. We tend to think that they track perfectly, but they don't. They tend to wander. And the deeper the hole, the more the chances are that it will wander a little bit. So in order to increase accuracy, in this case, and in order to, since it's going to end up two blocks, and in order to avoid that wandering, I'm going to punch, spot, and drill from one side down to the center, and that line will help me set the height or depth of cut on the drill press, then flip over and do the same on the other side. So I've set my height gauge up to half the height of this part, and all I want to do is just lay out a line. There, I have hand deburred the blocks, or these holes I should say. There is an accurate chamfer to be put in here. There is a chamfer and there is a dimension on the print, so I have to respect that. But I'm not going to do it right now. I could do it right now, but remember, this block still needs to be cut in two, and when I do cut it in two, well, I'll have a chamfer to produce. So to avoid another setup, I'll just do all the chamfering at the end, or before the heat treatment, but after the block has been cut in two. And that means, since our hole is there, that we're ready for roughing out the V. So let's head over to the milling machine. We're going to start by roughing out the V on the smaller of the two blocks. We're going to be using a 2-flute carbide insert mill, and we're going to be holding this smaller block in the vise. Now it's important to note that I've sank the part into the vise as deeply as possible, that horizontal surface of the V just barely protruding, because I want to hold it as solidly as possible. So let's come in a little closer and take a look at this setup. So I have my vernier protractor set at precisely 45 degrees, and it's mounted on a 1-2-3 block and clamped to the side of another 1-2-3 block, and both blocks, well, are clamped together. So this makes a nice, steady, stable setup to hold my protractor, and as you can see, it's abutting up to my part here at 45 degrees. Important that we get the 45 degrees in the proper plane. This is the axis that I want my protractor to be in. So I've leaned the scale up against the jaw of the vise to ensure that I'm in the proper plane. Now, another thing that's nice with this setup is once I've set up my part, I can move this out of the way and come back with it should I need to move the part somewhere later on. So now we have our safety glasses on, and all we really want to do here is remove as much material as possible, as quickly as possible. We're not going to be measuring here, we're just going to be coming up close to our laid out lines. We'll refine our cuts a little later once we can start to measure the centering of that V. What we want here is this V to be as center as possible on the part. So let's start by roughing out. So that bottom surface is quite nice, but the side surface, not so nice. I mean, these cutters cut very well on their ends, but not very well on their sides. Now the bottom surface is just flush with the line. Actually, I am where I want to be. I've just bisected that line in two. But the side surface, not even close. And I've done that on purpose because I'm going to center that V by cutting the side surface, but I want as good a finish on it as the one that I had on the bottom surface. So what I'm going to do here is flip my block over so that the side surface is on the bottom, and then I can come and cut the bottom without touching the side, and finish it up just as nice as the side, as the bottom one was on the last cut. But I'm going to want to measure because I want this V to be on center, and measuring a V isn't always easy. Well, it is if you know tricks. And here's one trick that's easy to do, and that is to use a pin. Now, I have here a 3/4 inch dowel pin, and it's very accurate. Now, I can rest this pin in my V. As I cut on the other side, I'm going to measure every now and then. And I'm going to measure from the side of my block to the side of the pin as it's resting in the V. Now, if I can measure that, and I can because I have this nice little depth micrometer, if I can measure that and I know what it should be, just like that, come down and measure the distance, well, I can make certain that that pin is on center, and if it's on center, it's because the V is on center. So what am I looking for here as far as numbers go? Well, I have a 3/4 inch pin. I have a 2-inch wide part. So 2 inches minus 3/4. That leaves 1 1/4. But I don't want to measure both sides, I just want to measure one side. So 1 1/4 divided by 2 is 5/8. 5/8 is 0.625, 625 thou. So when I measure from the side of the part to the edge of this pin, and it measures 0.625, I'll know that I am right on center. So let's flip the block over and start cutting. Now this is where that rigid setup for my vernier protractor comes in handy, because I just clean up, flip over, set back up, and I'm good to go. Well, I'm pretty happy with this smaller of the two blocks. You can see the V there is nicely roughed out, looking really good, and it's actually quite accurate. So less finishing later on, and that's a good thing. So we can set this one aside because we have a second block to rough out here, the larger of the two. Now, I have my vise here still mounted, and I could do the second block in the vise as I did the first. But the objective here is to learn, and I have received many questions about alternative ways of holding parts. In other words, fixturing. So I've made up a fixture here. Now, a fixture is a device or something that you make to hold and position a part relative to a tool. So generally speaking, when we're on milling machines, we're talking about a fixture. It doesn't guide the tool, it holds the part in relation to it. And a jig, well, a jig guides the tool to a position on the part. And that's why we call a drill jig and not a drill fixture. That being said, I have a small fixture here that's going to hold my part and keep it oriented properly for my milling operation once my position is set up. I have several things here. I have finger clamps, I have angle plate, I have a large V block, I have a 1, 2, 3 block, I have a brass pin, I have a C-clamp. And you can't see any of that or very little of it from your vantage point there. So come on in and we'll point out each part of this setup, and then we'll tear it down and install the part back again just so that you see how it's done. Okay, so I have 2 finger clamps holding down an angle plate. The angle plate is bolted with the 2 bolts here onto a large V block. The V block supports the part that I want to machine at 45 degrees, and the part that I want to machine, well, is held in the V block by this brass pin in its groove and this finger clamp bearing down on it. And then, well, we have this large C-clamp, and this large C-clamp is just ensuring that the part stays abutted up to the angle plate here. It's really a safety. I don't think we would need it to hold the part in for the milling operation, but why take a chance? Okay, so my part is set up and we're ready to start cutting. Not really. I still have to go get my safety glasses. Now, I'm not going to be showing all of the cutting operations here because it's going to be quite similar to what we did with the smaller block. I mean, cutting is cutting. Now, the main difference here is how we're holding the part. And that method of holding the part has one great advantage over the vise, and that is that I'll be able to turn my block over and cut to the same depth as I've cut the first side that I'm cutting now, and my V will be centered because it'll always be sitting in the same V block. I won't be changing the height when I flip the part over. So let's start cutting and we'll come back once the V is almost complete. There, our V is looking pretty good here. So you can see that that went a lot faster, or it was easier than it was with the small block, because the second setup was way simpler. So we took some time to set up the fixture, but it saved us a lot of time afterwards. Okay, so great. The V is roughed out and it's nice and centered. What's left? Well, now it's the groove in the bottom here that's left to do. So we'll be grooving the bottom, we'll be cutting the blocks in two, and then we'll be milling both sides of the insides of these blocks, the sides that we've cut, to their final rough dimension or pre-grinding dimension. So first thing is the grooving. We're going to be using a 1/8 of an inch slitting saw for that. We're going to set our piece up into the vise so that it protrudes enough to be able to get at the V here. I'm going to touch off the top using some shim stock, move off, come down half the width of my part, or the height of my part, plus half the width of the cutter, and that'll put the center of the cutter right on the center of my V. And then we'll cut there. How deep? Well, we'll cut to our laid out line, the one that we laid out, to show the depth of that groove right at the very start. It's not crucial here, so we'll just go with that laid out line for the depth. So we can tear all this down. We don't need the fixture anymore, and actually it's in our way, so we'll get rid of it, clean up. Our vise is still there, I haven't moved it, and it's still aligned, so then we'll set up for that groove. Okay, my 4-inch diameter, 1/8 inch thick slitting saw is mounted in my arbor in the spindle. And I've reduced my RPM. This is crucial. This is a high-speed steel tool. And remember, we know how to calculate this. It's cutting speed times 4 divided by diameter of what turns. That's the formula for calculating the speed of a high-speed steel cutter. Now, if you don't remember that formula, or if you have no idea what I'm talking about, you might want to check out my videos on speeds and feeds, and maybe you'll understand a little more. But if you want your tool to last, you have to respect those maximum RPMs. And in this case, well, I've gotten it down to about 70 RPM. The cutting speed of this 4140 is 70 feet per minute, times 4 is a constant, divided by diameter of the cutter in inches. It's 4 inches, so 70 times 4 divided by 4 is 70. So that's what I'm set at, and we're ready to cut for that. But how am I going to position my cutter? Well, I'm going to touch off the top of my part, and I'm not going to touch the part. I'm going to use this 10 thou shim stock to just come just barely to 10 thou from the surface. Then I'm going to back off. Then I'm going to come down by half of the thickness of this part. The part measures 2 inches. I want the groove to be on center, so come down 2 inches. Well, that won't put me on center. I'll have to come down half the thickness of the cutter then, because I want the center of the cutter on the center of the part. But I mustn't forget that I have this 10 thou shim also. So I'm going to come down 1 inch, 62 thou, 1.0625. We'll forget about the 5/10, and 10 thou more. So 1 inch, 0.72. 1 inch, 72 thou is what I'm going to come down once I've touched off. And that will be the center of my part. And then I'll just have to set up the depth. And we've already said we're going to do that by eye with the little line that we laid out on the end of the part here. So let's get to it. In our next video, we'll be looking at part 2 of this project, which is the clamp.